In this problem, we have to solve a 3 by 3 system of equations. That means 3 equations with 3 variables, x, y, z. And to do this, we're going to use an augmented matrix with row operations. It's not the easiest way to do it, but it is one of the techniques we have to learn. So you'll see what I've done first is I have transformed this set of numbers, 3, -9, 3, 12, into an augmented matrix like here, and I've done that for each of the equations that I'm given. Okay, and what we're now going to do, this is your answer to the first part, by the way, that's the augmented matrix. What we're now going to do, thank you, Apple, is I'm going to play around with these numbers in the augmented matrix, specifically on the left side of it, until they look like this, a nice identity matrix of ones going in the diagonal and zeros everywhere else. And once I've gotten it into that form, then what I'm left with on the right side, right over here, are all my solutions. Now there's a bunch of steps here, and because it's a 3 by 3, you can't do this in less than 9 steps. Well, I guess you could if you're clever. But I'm going to go through one possible way of doing this. There are many, but I suggest you follow this little flow chart here. First, second, third. That means I'm going to do these steps first in that order. And then I'm going to go up here, get that into a 1. Then I'm going to turn this fifth step into a 0. And then I'm going to work my way back up in this direction. Okay? No problem, right? Well, let's get started. So, step 1. I'm going to replace row 1 with row 1 divided by 3. So you'll see, to save time, I just went ahead and did all the writing. But I'm taking this row and dividing it by 3, and I get this row. Great. Well, what I accomplished with this was getting this entry to be equal to 1. That's the start of my identity matrix. All right, next step. Now I'm going to replace row 2 with row 2 minus 2r1. Okay, so this row right here is getting replaced by itself minus twice the row above it. And I want to focus on this right here. This is how I'm making this decision. I'm saying 2 minus 2 times 1 equals 0. That's the goal. Everything else in that row gets swept along for the ride, but my goal was to get a 0 in the second entry of this matrix. Third step, I'm going to take that matrix from the last step, and I'm replacing row 3 right here with row 3 plus row 1. And if you look at row 3 and row 1, look at the left sides, 1 and -1. What happens when you add those together? You get 0. That's my goal. Again, everything else in that row just comes along for the ride, but now I have 1, 0, 0 as my first 3 entries. That's a start of an identity matrix. Next step, I'm going to replace row 2 with row 2 divided by -2. Now, how do I decide to do divided by -2? That seems a little random, doesn't it? Well, take a look at this entry right here. I want that to be a 1. The only way to turn it into a 1 is divided by -2. Well, a way to get it to be 1. Everything else comes along for the ride. Next step, number 5, I'm going to replace row 3 right here with row 3 minus twice row 2. Okay, so the goal, again, is to use these two numbers to get the 2 to be a 0. So I'm going to take the third row, subtract twice the second row, and I get this guy. Now it's starting to look really nice. You can see the diagonal forming up. All I have to do is divide row 3 by 2. Okay, I'm going to divide that third row by 2, and instead of 0, 0, 2, -6, I get 0, 0, 1, -3. Great progress. The diagonal is formed. Now I just need to work my way up the top right. So what I'm going to do is replace row 2 with row 2 plus row 2, replace row 2 with row 2 plus 3r3. Okay, that's a tongue twister. Anyway, I'm trying to get rid of this -3 right here. That's my next step. I want to turn -3 into a 0. And to do that, I'm going to add 3 of these rows right here. You'll see I also say -7 plus 3 times -3. That gets me the -2, right? I don't care about the right column. Remember, I am completely focused on getting the identity matrix on the left. Okay, next step, I'm replacing row 1, this top row right here, with something to get rid of that -3. I want a 0 right there. So I'm going to add 3 of the rows below it, right? R1 plus 3R2 gets me right here. Okay, now this is really great. There's just one more entry. It's that top right entry. I would like that to be a 0. I will do that in the next step. I'm replacing the first row with row 1 minus row 3. Okay, so when I do that, this turns into a 0, this turns into a 1, and now let's stand back and marvel at not only a completed identity matrix, but I didn't make a single Star Wars joke with all these R2s flying around in here. I thought I would have had trouble with that, but okay, anyway, right here at the end, what do we have? I've got 1, -2, 3. Those are the solutions to all this hard work. You can plug those solutions for x, y, and z way back, way back here, up here in this equation, this set of equations. So you plug those in, it's going to solve every single one of those things.